Hi guys, welcome back to the channel. In this video, we are going to discuss another problem of the day, and like it was yesterday's problem of the day. And the name of the question is binary array sorting. You can also find the link of the problem in the description of this video, and you can try that problem. And you can also try today's problem of the day. So today's problem of the day is longest common prefix in an array. Okay. So you can try these problem of the day, and like the you already the new year has started, so you can take the new year resolution to solve at least one question every day. Okay, so like as I said, in this particular video we are going to discuss the solution for this particular problem, that is binary array sorting. Okay, and if you see the tags for this problem, the tags are arrays, sorting, and two pointer algorithm. So although this is a very basic level problem, but like if you solve these type of problem, they help you to understand the elementary concepts in programming, and these concepts help you to solve the bigger problems. Okay, so that's why like solving these problems are important, and definitely like you get an every day you get a new problem to solve. Okay, so like some of the problems are medium level, some of the problems are of hard level. Okay, so if you try to solve at least one problem every day, then it will help you a lot in long run. Okay, so this is the main idea of problem of the day, as you know. And let's quickly like get back to the question and discuss the solution for the today's problem. Okay, so the name of the question is binary array sorting. This is a basic level question, and let's read what is the question. In this question, you are given with a binary array, okay, of size n, and your task is to arrange the array in increasing order. So what's a binary array? So binary array, as we know that binary means zeros and ones. Okay, so binary array is an array that contains only two type of element, and either the element could be 0 or the element could be 1. Okay, so hi Nathan, hi Gaurav. So what's a binary array? A binary array is a array that contains only two type of element, either it is 0 or it is 1. Okay, and you have to like you are given with a binary array of size n, and you have to sort this array. Hi Sachin Best. Okay, so how definitely Nathan, you can apply, like you can say like sort, you can just call the sort function, and you can like do something like this. Okay, you can call the inbuilt sort function, but what is the time complexity of that particular inbuilt sort function? As we know that it is n log n. Okay, so that's n log n. Can we think in such a manner that there are only two types of element, okay, zeros and ones. So using that, can we improve the time complexity from n log n to something like order of n, or something like that? Think about that. Okay, definitely we can call the inbuilt function, that is call any sort function in either Java or in like Indian other language. Okay, so like this problem could be solved in different ways. As we said, we can simply call the sort function. Okay, so that will take the time complexity will be order of n log n. Other The other method that we can use is something like counting sort. Okay, so we can use counting sort, something similar to counting sort. So here we only require just order of one space and order of n time. Okay, so is it better than the previous approach that we are discussing? Yes, it is better. Okay, so this problem could also be solved using two pointer approach. Okay, so this pointer, like this question could also be solved using two pointer approach. So if you solve using two pointer approach, then you will get a better hold on this particular approach that is called as two pointer approach. Okay, just if you understand how the two pointer approach works, then you will get better idea about two pointer approach, and it will help you to solve bigger problems. Okay, Nitin, like I'm not able to get your question. Like if you could just paste the screenshot of the code or something like that, then I would be able to answer your question. Okay. So let's like we already discussed that we can use this. Now let's discuss this counting sort or the second method. Okay, so here what we can do, as we know that we have only two types of element, that is zeros and ones. Okay, so first of all, in one pass, what we will do, we will count all the number of zeros. Okay, what we will do, we will count the number of zeros. Okay, so let me write it. Count number of zeros. Let's say that that is equal to this count value. Okay, and in the second pass, what we will do, let's say that this is my array. Okay, and let's say that the count value was equal to 4. Okay, so it means that there were total 4 number of zeros. So what I'm going to do, I'm going to put 4 zeros in the front. Okay, so this array was like original array that is given in the question. What I'm going to do, I'm just going to put 4 zeros in the front. Okay, and the remaining I'm going to put 1. So say this is also sorted. Okay, and what we did two passes. Okay, or two traversal of the complete array. In the first, we just counted the number of zeros. Okay, and let's say that it was equal to this count variable. Okay, yes, Nitin, like you can say that the time complexity is n plus n log n, but like when we discuss the overall time complexity, we just ignore these lower terms and we just take the higher power terms. Okay, and if you see, this will exceed and this is higher power term, so that's why we'll say that uh, the complete time complexity of this particular problem is order of n log n. Okay, like as you said that can we write something like this? So we will say that the time complexity of the algorithm that we gave was equal to n log n. Okay, so let's get back to the solution. We said that we will just do true traversal of the complete array, and first we will just count all the numbers of zeros, then we will fill all the zeros from starting. Okay, equal to this particular count variable, and the remaining I will fill with zeros. Okay, so let's quickly see the code for this, and we will discuss the let's also discuss the time complexity and space complexity after seeing the code. Okay, so as I said, we are going to use a count variable to count the number of zeros. Okay, so what this count variable is going to store, it is going to store the number of zeros, and this I variable I am using for the traversal in the complete array. Okay, so let's first of all, this is my first pass. Okay, let me write it. This is my first pass. So here I will just count the number of zeros, the total number of zeros present in this complete array. Okay, so I will run a loop from for I assigns to 0, I is less than n, I plus plus. I will just increase my count variable if my current element is equal to 0. Okay, so it will give me the total number of zeros present in this complete array. Then I'm going to do what? Then I'm going to iterate over the complete array once again. Okay, and starting from the beginning, if my count value is greater than 0, then what I'm going to do, I'm just going to fill my make my current element equal to 0. Otherwise I'm going after that I'm going to decrease my count variable. Okay, because I have utilized one zero. Okay, otherwise I'm just going to put the current element equal to 1. Okay, and if you see in the final what we will obtain whenever we have iterated both these passes, so we will get the sorted array. And what is the time complexity and space complexity? See here. Okay, so the first loop only runs for order of n time. Okay, and the second loop also runs for order of n time. So the time complexity is n plus n, that is order of 2n. And if we ignore the constant part, we can say that the time complexity of this particular question is order of n. And what about the space complexity? So the space complexity is nothing but constant, because we haven't declared any extra array, any stack, any queue, something like that. Okay, so as we discussed, the time complexity of this approach was order of n. The space complexity of this approach was order of 1, that is constant. And here we required two traversal of the complete array. Okay, so here we required two traversal of the complete array. Now let's back to like if you have any doubt in this particular approach, then please do ask. Otherwise, we are going to discuss the second approach, that is called as two-pointer approach. Okay. So now we are going to discuss the two-pointer approach. Till then, if you have any doubt, then please do ask. Okay. In the previous approach, so it was very basic approach that we just count the number of zeros, then fill in starting just fill the all the elements with zeros till your count is greater than 0. Okay, and at every time you utilize 1 0, just decrease the count variable. Okay, otherwise just make the current element equal to 1. Okay, so that was a very basic and standard approach. Now we are going to use the second approach, that is called as two-pointer approach. Okay, so as the name suggests, here we will be using two pointers. Okay, so like either you can name the two pointer as left or right, or you can call them ing. Okay, so we are going to call them ing. Okay, so what I will represent, so starting I will represent that all the elements that are present before this particular ith index. Okay, so all the elements that are present before the ith index, those are going to be okay. So Gaurav says that it is clear. Okay, great. So ith pointer will tell you that it will confirm that all the elements present before the ith index are going to be 0. Okay, and what j says, so j is confirm that, or it says that all the elements present after this particular index are going to be 1. Okay, so after jth index, all the elements are going to be 1, and before this ith index, all the elements are going to be 0. Okay, so this very basic thing, and this should be clear to you. Okay, and we don't know about the elements that are present in between I and j. Okay, so we will just go from starting of the element to each and every element. Okay, and then we will process it. Okay, either it is going to be 0 or it is going to be 1. Okay, but the one thing is here is confirmed that all the elements present before the ith index are going to be zeros, and all the elements present after the jth index are going to be 1. Okay, so we are going to use two variables or two pointers ing. Now let's take an example and see how we will solve this question. Okay, so let's take this example, that is 1 0 1 1 0. Okay, so we have 1 0 1 1 0. Okay, so I am saying that all the elements present before the ith index are going to be what they are going to be 0. Okay, and all the elements present after the jth index are going to be 1. Okay, so this we are going to get confirmed. Okay, and the now here trick point is that, okay, ith index will move from the here. Okay, and jth index will move from n minus 1. Okay, it will move in this direction, it will move in this direction. Okay, and the ith index will stop at that particular point wherever it finds a 1. Okay, so I will stop at, so let me write it, I will stop whenever we find 1, and j will stop, like you can quickly guess, j will stop whenever we find a 0. Okay, so let's see how this is going to help us. Okay, so my I is going to move from left to right, my j is going to move from right to left, and I will stop whenever we find a 1. Okay, see here, I will stop whenever we find a 1, and j will stop whenever we find a 0. Okay, and one more thing that we discussed is that before I, all the elements are going to be 0, and after j, all the elements are going to be 1. Okay, so let's do the let's quickly dry run on this. Okay, so for like my I will start from here, and it will say that I just found a 1. Okay, so I will stop whenever it finds a 1, so I will stop here, and j will start from the end. Okay, so here is my j, and it will say that I will stop whenever I find a 0. Okay, so my j will stop here because the very first element is the last element is 0 itself. Okay, So whenever you found that I is less than j, okay, it means that there was a condition that these two elements could be swapped. Okay, so what we can do here is that we can just swap these two elements, that is the a of I and a of j. Okay, so let's just swap these two elements. So what I'm going to do, I'm just going to swap these two elements. I'm going to make it 0. I'm going to make it 1. Okay. So see here. Now this is correct. 0 is appearing before 1. Okay. So after this, what I can do, I can just move my I pointer 1 forward and I can move my j pointer 1 backward. Okay. So this is the main algorithm. Okay. So what we are going to do, we are going to move our I from left to right. We are going to move our j from right to left. I will stop whenever it finds a 1. J will stop whenever it finds a 0. Okay. And whenever I is less than 0 and they have stopped at such one particular point. Okay. At that point, we are just going to swap those two elements. Okay. So now my I will come here. So this is the main algorithm. We will discuss the time complexity and space complexity. Okay. So let me write it here. Now my I has moved up to this point. Okay. And now my j is pointing to this point. So see here. So this is 0. Okay. And 0 is correct because like we want zeros in the beginning. Okay. So what I'm going to do, I'm just going to move it one more forward. Okay. So my I will move one forward. So now my I will move up to this particular point. Okay. So my I will come here. See here. At this particular point, you found a 1. Okay. So you are going to stop this. Then we are going to move j. Okay. Because I has found a position where it found a 1. Okay. So it will stop here. Now j is going to move from backwards. Okay. And it will stop whenever it finds a 0. So see this. This particular element is 1. So it is not going to stop. It is going to move. Okay. And j will come at this index. So let me erase this and move the j pointer. Okay. So now my j is going to move here. So see here. I and j have came to the same point. It means that all the elements are already sorted. Why? Because in the initially what we discussed one important point, that all the elements present before like this particular I index are going to be 0, and all the elements going to present after this particular j element are going to be 1. Okay. And because I and j are pointing to the same value, it means that either that particular element is going to be 0, like either it is going to be 0 or it is going to be 1. But we can stop here. Okay. Because this is the meeting point wherein like the array is already sorted. Okay. Because that particular condition is satisfied, that all the elements before this ith index is going to be 0, and all the elements after that jth index are going to be 1. Okay. So that's why we can stop here. And I hope that this approach is clear to you. If not, then like let's see the code, then it will be more clear to you. Okay. So like we are going to use two pointer approach as said. So we will declare two pointers. The first one is the I pointer. Okay. And it will point to the starting of the array. And the second pointer is j pointer, that is going to point the end of the array, that is n minus 1. Okay. So there are n elements. So the last index would be n minus 1. Okay. So as we discussed, we are just going to iterate, move this left pointer and move the right pointer till my I is less than j. Okay. So till my left pointer is less than or like less than my right pointer, I am going to do something. Okay. And what we are going to do, we are going to move the ith pointer till it finds the 1. Okay. So till the elements are say 0. Okay. So till the elements are 0, it is going to move, and whenever it finds a 1, it is going to stop. Okay. So this is the main idea that we discussed. This is how my left pointer is going to move. Okay. So while I is less than j, so that is the main condition that we need to check. Okay. And till my current element is equal to 0, it means that I am continuously finding zeros. Okay. It means that my I is continuously pointing to zeros. Okay. Till then, what I'm going to do, I'm just going to move my I pointer one forward. Okay. So that's why I will do I plus plus. Okay. So while I is less than j and while the a of I is equal to 0, it means that we are going to move our I pointer. Okay. And while I is less than j, so that is the main condition that we have to check, okay, so that we don't like collide and move forward, okay. Then till a of j is equal to 1, then we are going to decrease the j pointer, okay. What does it mean? So this was for il like left pointer, and this is for j pointer, okay. So it means that till I am finding 1, till my j is pointing to ones, okay, it means that I can move backward. But whenever it finds a 0, okay, so I need to stop there. Why? Because I need to swap these two elements, okay, because these two elements are not at their position, okay. So that's why my j will stop whenever it finds a 0. So that's why this condition is written here. Till my the a of j is equal to 1, then I'm going to decrease my j pointer by 1, okay. So while I is less than j and a of I is equal to 0, I'm just going to move it 1 forward. And while I is less than j and a of j is equal to 1, I'm going to decrease my jth pointer, okay. Then what? Then this is the main condition wherein we swap these two elements, okay, because these two elements are not at their position. So that's why I will check if I is less than j, okay. If I is less than j, I'm just going to swap these two elements, okay. So I will swap a of I and I will swap a of j, okay. And then I'm going to move this j pointer 1 back and move this I pointer 1 forward, okay. So I will just do if I is less than j, swap a of I and a of j, then do I plus plus and do j minus minus, okay. So this is the main code. Let's try to run and compile this, okay. And if you have any doubt, then please do ask, okay. So see, for this particular condition, we are getting the correct output. Let's also try to submit this, okay. So there's some issue at my end. Okay, so these are like this is the solution, okay, and I hope that this is clear to you. And here, like we discussed, two types of solution. The first one, uh, thank you Gaurav for understanding, okay. So like we discussed two main approaches. The first one was to use the counting sort, okay, and there we required two traversal of the complete array, okay. So there we required two traversal of the complete array. Then we discussed the two pointer approach. And let's now compare both these approaches, okay. Let's now discuss the time complexity of this approach that we just discussed. So see here, here we are like utilizing one loop. There is one outer loop and there is one inner loop, okay. So can I say that like by just seeing the these two inner loops, okay, can I say that the time complexity is just order of n square? No, okay. Why? Because I have to analyze these two uh, how these arrays are working, okay. So see here, so both these arrays are just dealing with like two variables, that is I and j, okay. And see how my I is moving and how my j is moving, okay. So that we have to see, and whatever the way they are moving, that is going to decide what is the time complexity of this particular question, okay. See here, my I pointer is going to move from left to right and my j pointer is going to move from right to left, okay. And you take any one element, I'm just going to process it only once, okay. Either I'm going to stop there, okay, either I'm going to stop I and j, okay. If it is 0 and if it is 1, I'm going to stop and then I'm going to swap, okay. Then also I'm just going to process it once and then I'm going to move forward, okay, and I'm going to decrease my j pointer, okay. Otherwise I'm just going to directly move forward if it's equal to 0, okay. So any element is just processed at most once, okay. What does it means? It means that if I have total number of n elements, each element is going to get processed at most once, okay. It means that the time complexity of this solution is going to be order of n, okay. Why? Because my I pointer is continuously moving forward, a j point is continuously moving backward, and whenever they meet, they are just going to stop, okay. my algorithm is going to stop whenever they are going to collide with each other. Okay, so that's why the time complexity for this complete loop is just going to be order of n. Okay, so I hope that this is clear to you, and if not, then please do ask. I will explain it again. Okay, so as discussed, the time complexity of this particular the two pointer approach that we discussed is going to be order of n, and the space complexity is going to be order of 1. Why? See here, we haven't declared any extra array, any extra vector, any extra stack or something like that. We're just utilizing two variables, and this the space that we are going to take for this particular problem is not going to depend on the number of inputs that we are going to get. Okay, it is always going to be constant. Okay, so that's why the space complexity is going to be order of 1, that is constant. So someone says that what's the Python code? So Python code is not going to be get very much different. Okay, you just need to change the loops. Okay, you just need to remove these particular braces. Okay, then I think that the rest of that is going to be same. Okay, so if the algorithm is clear to you, you can simply code it in Python. Okay, so like we were comparing both the approaches that we used. So see here, like the first approach that we used to was to do counting sort, wherein we count the number of zeros. So there we required two traversal, although the time complexity was equal to order of n and space complexity was equal to order of 1. Okay, and that is same as we discussed in this second approach. Okay, but in the first approach, we were traversing through the complete array two times. Okay, we were traversing through the complete array two times, but so it required two traversal of the complete array. But here we are just traversing through the complete array just once. Okay, so in just one traversal we are able to solve this question. So although like the time complexity and space complexity is same, but here we just require one traversal to solve this particular question. Okay, so if you solve this particular question using two pointer approach, then it will help you to understand the two pointer approach in better manner. Okay, and it help you in when you are answering in interviews. Okay, the interviewer can ask you for two pointer approach as well. Okay, so these are the things where it can help you, and I hope that like both the solutions are clear to you, and if you have any doubt, then please do ask. Okay, and if you want to know something else, then you can also ask that. Okay, so I would encourage you guys to please also try today's problem of the day. Okay, so that is longest common prefix in an array. Okay, so if you see, this problem has been asked in companies like VMware, Microsoft, Google. Okay, and that's a like good problem. So you can try this problem of the day. You okay? Uh, yes, like we cannot. Second, Gaurav, we can say that the second method is more efficient, although the time complexity and space complexity are same. But as a candidate, as an like computer science student, you need to know both the approaches and know more and more approaches. Okay, so if you know, there is one more question similar to this, wherein we have three types of element. Okay, we have 0, 1 and 2, and that is also solved using two pointer approach. Okay, so there also we can just apply counting sort. We can, instead of only having count of zeros, we can have count of zeros and count of ones. Okay, and we can solve that particular problem. But there also we can use two pointer type of approach, that is called as DNF approach. Okay, that's national flag algorithm. Okay, so I would encourage you to also go ahead and try that particular problem, try to solve that particular problem, and if you are able to do, then tell me tomorrow. Okay, otherwise like we can also discuss that particular approach also, wherein we have three types of elements, that is 0, 1 and 2, and that we have to solve. So if you try to solve this approach, like using two pointer approach or this DNF algorithm, then it will help you to understand these fundamentals in better manner. Okay, and I hope that there is no doubt in today's problem of the day. Okay, and if you have any doubt, then please do ask. Otherwise, I think that we are good to go and we can end today's session. Okay, and once again, thank you for being here and making the session quite interactive. So I'll just wait for a few more minutes or a few more seconds, and then if you don't have any doubt, then I will end today's session. Okay. As I said, also go and try the today's problem of the day. Thank you, Gaurav, and thank you, everyone. Okay. So I get that the solution is clear to everyone. Thank you, guys, and have a great day ahead. Okay.